today we want to talk about finding the equation of a plane, all right, or a surface in 3 dimensions. So how of a plane? Um, so we want to find the equation of a plane. We need two things. We need a vector in the direction of the plane. And we need two vectors. And we need a vector perpendicular to the plane. Yeah, so we need a vector perpendicular to the plane, which you see in the diagram here is called n. We need a vector that is somewhere in the plane. So let us say that every point in the plane can be x and y and z, and then we are going to be requiring to find another vector, which we're probably going to call p or some other name. Well, let's call this vector call it like x. So we need two vectors. We need one perpendicular to the plane, which we're going to call n, and then we're going to need the next vector, which we're going to call. So let me draw the rough diagram. I just wanted you to see the neat diagram there, and then so I'm going to draw. Oops, I'm already. All right, so let's work out a problem. So let us say that we have 3 points in the plane. All right, so we have A, B, and C. We want to find the equation of the plane. All right. So So we're going to call first point. So this is A. I'm going to use 3 different colors. This is A. This is a point. This point C. So how do we find the equation of the plane? Well, all right. So first of all, we're going to write the position vector of the 3 points. Position vector O to A is 2, 3, 4. O to B is 5, 1, 6. And O to C is 6, 1, 7. So now, our task, like we said, is to find the equation that governs it. So anybody writing or can move on to the next page or?
Can move on.
Wait, give us a couple more seconds.
All right. So while we are writing, just bear in mind that A, B, and C are three points in the plane. And we are saying that the 3 points in the plane, those 3 points in the plane, we are going to need 2 things to out what the equation of the plane is. So we're going to use 3 points to work out 2 things. So tell me when I can move.
I am finished now, sir. I don't know.
Yes, sir.
It is asking me to do this before I edit profile picture, which I want to do, but that's not the point. Okay. All right. So I need to find a vector perpendicular to the plane. But I have A, B, and C. So I can find the vector A, B. So if you recall, all of these came from the point O. So this is our point O. So AB would be AO plus OB, or OB minus OA, whichever one suits you. So AO would be the opposite. That's minus 2, minus 3, minus 4. And OB is 5, 1, 6. So plus 5, 1, 6. So therefore, AB would be equal to 3, negative 2, 2. And AC would be equal to similarly AO plus OC, which is going to be AO, which is minus 2, minus 3, minus 4, plus 6, 1, 7. 6, 1, 7. So last week, Wednesday, we said that if we want to find a vector perpendicular to AB and AC. Now, AB and AC are two vectors that are in the plane, and I want to find N, which is perpendicular. So to find a vector, we find AB, the cross product of AB and AC. So N is going to be equal to I, J, K, B is 3, negative 2, so that's 3, negative 2, 2. AC is 4, negative 3. So our vector that is perpendicular, we can find AB and find AC, and the vector that is perpendicular to both of them is the cross product of the two vectors that we have found that are in the plane. So that's the first thing that we have to find. Vector that is in the plane is AB, and another vector that is in the plane, parallel to the plane, is AC. So now we can multiply and find, we can use the method of finding the determinant of a 3 by 3 to find the vector N, which is perpendicular to both of them. All right, so tell me when you can just do the calculation.
Yes, sir.
Ready? All right. Okay. So let's find that. 3, -2, 2, 4, negative. Right on that first. 3, oops. -2, 2, 4, -2, 3, I, J, K, determinant, and that's my vector n. So n is equal to times -2, 2, -2, 3. Cross out the row and column that the vector is in. So if you cross out this row and this column, then what is left is what we find.
Then it will be plus J.
Minus.
Sorry, minus J, yeah, minus J.
Yeah. Minus J.
Then it will be 3, 2, 4, 3.
4, 3. Then it's plus
Plus
K.
K, which would be 3, -2, 4, -2.
4, 2. So that is going to be I times this is -6 minus -4 minus J. That is 9 minus 8 plus K -6 minus -8. So that is going to be -2I minus J plus 2K. So we have our plane and we have our n, which is perpendicular to the plane. So that's the first thing that we need. All right, then we can move to the
So I have minus 2J minus J. Doesn't
I
go
again?
minus 2I.
Oh, sorry about that. Two I minus J. So n is -2I minus J minus 2K. Yeah, like I said, tell me when we can move.
I'm finished, sir.
All right. So now, the next step that we are going to go to is I want us to consider.
Over the top, you have minus 2I minus j minus 2.
Plus.
Okay.
All right, so now we're back to our plane again. And we say that we have a point n minus 2I minus j plus 2k. Now I want us to consider an arbitrary point in the plane x. And x is just x, y, and z. So this x that is in the plane, we just call it x, y, and z. And we're taking it from the point A. Now, A, x. Now we say that, well, let me write this down first. Now we already had OA. And now we're having x. So from the point O, we're saying that any arbitrary point that I'm calling x, y, z, any point in the plane, I'm calling x an arbitrary point in the plane. We can write down ax as being equal to AO plus OX. And AO was minus 2 minus 3 minus 4 plus OX is x, y, and z. So that would give me x minus 2, y minus 3, z minus 4. So this is my AX. So a point that we want to note now is that when two vectors are perpendicular, their dot product is 0. And that comes from the formula. So A, if we were to find the angle between two vectors, let me just write it down here. Let us say this is OA and this is B. That OA will, the angle between two vectors is OA dot OB is equal to the length of OA, length of OB cos theta. If theta equal 90, then cos 90 is 0. So therefore, OA times OB perpendicular. So what we're saying now is that this vector n, put the x on it. This vector n and this vector ax. And remember now, x is any point in the plane. So if ax lies in the plane,
An angle.
which one?
Note that when two vectors are
Perpendicular. Short term.
all right, sir.
So the shorthand for perpendicular. So when the two vectors are perpendicular, then so we can write x dot n is equal to 0. And let me use this for the chart shorter. As long as there's a point x, y, z anywhere in the plane, then ax would be equal to x minus 2, y minus 3, z minus 4. And this vector times the dot product of ax and n must be equal to 0 since they are perpendicular. So that sets us up to find the equation of the plane now. Let me rub out the confusing symbol for all. All right, so tell me when you can move.
1 second, sir.
Sir, the symbol that I rubbed out, sir, that was supposed to be angles for all angles x in the plane, or just for all x in the plane?
For all x, for all points.
All right, thank you, sir.
So let me write it properly. For all points so we can move.
So do you think?
All right, so we say ax times n is equal to 0. And ax is x minus 2, x minus 3, x minus 4. Now that, let me just make sure.
Sir, wasn't it X, then Y, then Z?
Yeah. Well, yeah.
So it should be X minus 2, Y minus 3, Z minus 4. But you have X minus 3, X minus 4 when you go over to the next page. Yeah, you have X's. Yeah.
Oh. We're not here. And for n, negative 1 and 2. That's the same thing as minus 2i minus j plus 2k. So we can just write that negative 2, negative 1, and 2 is equal to 0. So that negative 2 x minus 2 plus negative 1 y minus 3 plus 2 z minus 4 is equal to 0. Some people leave it in this form and some people multiply it to minus 2x plus 4 minus y, 8. So that is minus 2 minus y plus 2z is equal to 8 minus 4, 4.37. So this is equal to 1. So this now is my equation of the plane. So minus 2 minus 2 x, y, z is equal to 1. You can write it like that as a dot product.
So, sir,
Mhm.
now the question become, what can we do with this equation?
What can you do with this equation? We're working with ever here in electromagnetic. That is where we're heading. That's not where we are, but that's where we're going. We didn't tell you that we're going there, so you wouldn't know. So, like in electromagnetic, when you find the field to things. So, for a lot of things in the electromagnetic area, you have to be able to find the equation of planes and lines to be able to calculate what is going on with 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 the field at a given point, or not only at a given point, but is sorry, yeah, magnetic flux density, which is talking about a point, and then magnetic flux is talking about the strength of the magnetic field over here. We are playing, and then so we have to find the equation. So that is where we're heading, but we have to go through all of these basics first, right? To find the area of the plane and the area of the surface and all those type of things. But with a few of those problems. Right? So and electromagnetics is the, the most hated part of physics engineering, most engineering because all of these well, quite frankly, when I was doing that, I was going on class.
Sir,
Um,
this last year. No, it's already.
or well, it should have been to help you. It should be to help you. Should have been to help you last year but that is what we're another question. And, okay, where was I? Oh, we're look at a question and try to see if we can sort out what is there. We're going to give it to you to do. So bear in mind what you have to do. You have to find the equation of the plane. You have to find a vector perpendicular to the plane and find a vector. Okay. Let's go. If I can bring up the question. Trying to find the question. Give me a second. Give me a second. Sorry, I can't find the question.
Already na yaya and take a tea quiet.
Oh, that's all like politics. So. All right. Well, and these are, well, I was taking the question out of, but it's the same thing they're asking. So, all right. I already requested, and I give you 3 points. I was trying to find another more interesting question, but all right. So. All right, so let me just bring up something that I'm going to ask you to write down. All right. Just have a go at this question. Number 20, number 30 for me, please. Sorry, number 31.
So are you making us do 31 so that we don't have to work with the fraction?
Yeah.
Okay, thank you.
That was the thinking, actually. That was the exact thinking. Came out of the fraction. This is out of the engineering maths book, by the way.
We have the book, as well?
All right, I'll put it in the group.
Okay.
Seems like a very long time ago. The phone is out of space. So I probably deleted it, but if you want me to put it back there, then I can.
Sir, I don't know if I'm me alone, but now your mic.
No, I'm talking.
Oh,
I said work out number 31, so we're giving them some time to work out number 31.
oh, never
Work out number 31.
Did you have the answer already, sir?
Yeah, but it's further on, so not moving it yet. What
All right,
did
so
you
I'll just wait until the others are finished.
All right, so like we got a they got a head start. Let's see. So it's 1, 2, 4. And what was the other one again? A was 1, 2, 4. C
One
was 4,
negative 2, 6.
1.
One negative 2 and 6.
So what's the first thing you did now? So
First thing I did was to calculate the vector A to B.
Sir, 1, 3, 4.
Do you want the entire processor or do you just want the answer?
So it's AO plus OB. And what's the answer?
0, negative 5, 2.
And then
Then I calculated A to C.
so AC, what did you work out that to be?
So I worked out that to be 3, negative 3, 3. So 3, negative 3, 3. Right.
And then
Then I do the cross product of both of them in order to find the normal.
so that would work out to that determinant.
Minus that plus K with 0, negative 5, 3, 3.
All right. And then what did you get N to be?
Right. So for N, I got negative 9I plus 6J plus 15K.
Plus 15K? Oh, yeah. Yeah.
Wait, Bonnie, we're trying to ask how I got positive 15K.
No,
That's
no, no,
correct.
no, no, no. You're right. I didn't. I forgot
Oh.
that the right hand diagonal always be negative. So I forgot to, make it positive.
Yeah.
All right. So moving right along.
So then I wrote the equation for AX.
Sir, the J is supposed
For
to
that,
positive, negative.
repeat.
Supposed to negative.
Let's see.
No,
J
no, the
is
number.
being multiplied. So be negative J times 0 minus 6. So be negative bracket 0 minus 6. Because it's negative, it's multiplying negative 6 and it's a negative J, it will turn into a positive 6J.
Correct. All right. So your AX work out to what now?
X minus 1, y minus 3, and z minus 4. Then you find the dot product of the normal and the AX. And that works out to be negative 9x. The n was negative, well, yeah, negative 9, positive 6, and positive 15. equals 0. So negative 9, Wait a sir, that's supposed to be a -3. You have y plus 3.
-3.
Yeah, yeah. When you're writing the 6, yeah. So it'll be negative 18. Right. Negative 9x plus 6y plus 15z and is equal to 69.
Okay. This dot product.
Negative 9, 6, 15 equal negative equals
Sir,
right.
go back one
Sir,
page.
could we simplify by dividing both sides by 3?
Yeah, we could. Actually, we prefer to divide by 3. That's 3x
Minus 3x plus 2y plus 5z equal minus 3x, yeah.
Yeah, and that will give us -3, 2, 5. So we can write that as equation as well. All right.
Plus 15, sir.
Yeah, because this is 0
0 times -3 is 0.
minus
5, 3. -5 times 3 or -15.
Remember, say minus it.
Yeah, and because you're subtracting a negative 15, it becomes a positive 15.
Okay. Remember, just left it 0 alone.
Oh. All right. All right. So we're not going to do anything more.
You can go to the next page.
So next question is the same thing. So I want to go to the next part of what we are going to be doing. We need to have a little discussion. Let me explain where we are. When we do the next topic under this whole thing about vectors, and I'm choosing my words very carefully because I don't know what happens. Anyway, so let me just. Your test is up. Your final exam is up until the end of the topic that we are going to do. But we have some other things to teach you, which most people do not like. But I still need you to come. And we are going to give you an assignment to work out that aspect of partial differential equation. We're describing waves and so forth, and those kind of things I'm going to teach will not be examined, but I still need you to come to class. So, but I'm telling you from
That's not so easy.
But
to come to class
No. Okay.
Sir, sir.
It in the that you are going to be getting. So so the next topic that we are going to be talking about is curl and divergence and gradient. All right. So, but we're not starting that today. We will be starting that next class. Defining it and explaining what it is for. All right. So we're going to stop here for today. Next class we talk about curl and divergence and gradient. And then we're going to talk about when you get to your first test and when you get to your second test and have that sorted out before.
First and second test.
Yes.
Sir,
Oh, the second test is the final. Okay, sir. Right.
Yes, basically.
Okay.
sir,
But not really a final.
No.
sir, sir, my question. How do you set up the system though?
Stop recording now, yet.